Hello and welcome to C Programming lecture series. In this video lecture, you will learn about Introduction to C Programming. So, we will see two topics over here. First is basic structure of C program and second is executing a C program or C compilation process. So, in this video lecture, you will learn about how the C program is written and how does it look like, and basically C is a high level programming language. So how this user understandable code will be converted into the machine code. So let's start with basic structure of C program. So usually everyone will start learning a C program with a hello world program, but we will see in a little bit different way. So we will see what are the basic body of the C program. So I have divided it into the two parts. The first part is a include part. So here you can see that we have has include stdio.h, which is basically a standard include for library, and here we have the comment. So comment is start with this kind of 2/, right? And then we have a has defined a pre-a which has a value of 10, and this is a multiple line comment. So basically C will have this kind of include section where we will include some libraries generally written with .h file, right? Then we will have some defines, the macro we will see in detail, but this is the one example has defined, right? And also some of the function prototype as well as some global declarations. So this is the first part of a C. Then the second thing you will see is the main body. So main body will have a main function. So every C program will start executing from this main function, and this main function or any function will have a three things. One is a return type, which is over here you can see as a int, means integer. We will see all data types also, but for now we will call this as an integer, which will just return any integer value, right? And then the function name. So here the name of function is what? Main, right? And the third thing is the function argument. So we are not passing any argument to this particular function, so that's why we have written it as a void. And as the return type of this function is integer, in the end we can see that we have a return 0, which will return a 0 value. If this program is executed successfully, it will return a 0 value after this function. So C will have a main function, and after that the function body will start. So function body means whatever which is written within this curly bracket. This is the beginning of the main function and this is the end of the main function, right? And within this function we will have our logic. For example, here we are saying that integer variable b, so where b equal to 7, this will copy the 7 into where b, right? Or we can say it will assign a value 7 to the where b. In the next line we have a where b equal to pre-a. So pre-a is already has a value of 10 over here, so that will be copied into variable b. And next line is a printf. So printf will display a message on the screen, and we will see the message whatever written between these two inverted comma, right? So here we have this where b, then the value. So this for percentage the where b value will be considered, then it will write pre-a, and then it will print the value of this pre-a. So we can see that we are expecting output as a where b colon 10 and pre-a colon 10. So this is how C program look likes, and I hope you are clear with this include part as well as this main function and its body. So in a previous slide we have seen that how does the C program look like. Now we will see how C program get compiled and executed. Whatever we have seen in previous slide, that is a high level C program, right? And that can be understood by the user, but that cannot be understood by the machine. So Compiler will convert that user high level program into the machine level or machine understandable format program, and then we will execute it. There are certain steps for it, so we will see each of these steps. It is not necessary we need to do all these steps every time, but this is the first time, so I will show you in detail how these things will be executed. So the first step is to have a source code. So source code is having an extension of .c. We can give any name to it. So code written in text editor with .c extension is called as a source code. So to have a source code, you can use any text editor or you can use any IDE, right? For example, VS Code or Eclipse or any other favorite IDE. You can also write in an online C programming debugger. So there are so many ways. So to start with, I will write that code into the Notepad++. So here you can see that we have this Notepad++, and I will just copy paste that program over here, right? Whatever we have seen in the first slide. And as of now, we have not saved it. So we will save this program with .c extension. So you can select a C source file over here and you can give a name as, let's say, hello, right? And click on save. So this is our first C source code is ready. Then the second step is a preprocessor. So preprocessor will generate a .i file. So what preprocessor will do is it will include the header. If you recall, we have one header file, standard input output.h. Then it will expand the macro or replace the macro. So in our case, it was a pre_a which has a value of 10. So we will see how it get expand, right? And it will also remove the comments. So we will see what is the difference between the .c file and the .i file. So first we will generate the .i file and then we will compare it. So this is the folder where we have this hello file, right? And what I will do, I will just write a cmd over here, so it will open the command prompt. Now here we will write one gcc command. So in order to compile this program, I have installed the minjw. You can also install the minjw and compile this. So we will write gcc, then -e, then our file name, that is hello.c, and output file we want is hello.i, right? So once you will click enter, this file will be generated over here. You can see hello.i. So I will just right click over here and also open in the notepad. So you can see that this is hello.i file, which will have all the inclusion of the whatever we have header file that we have included, and after that it will have simplified code in the end, right? So we can see that earlier our program hello.c was looking like this. It has a comments, right? And it has a this define pre-a as a value of 10, right? But if we see over here, so there are no comments. Pre-a is already replaced with this 10 value. Here also it is replaced. So this is how the hello.i or any pre-processed file look like. So the next step is a compiler. So usually we have sometimes compiler and assembler combine, or we can see it as a separately also, but we will see the compiler process, and the first thing is to generate the assembly code. So compiler will convert the process source code into assembly code, right? And it will have an extension of .s. So let's see how we can generate this assembly code and what will be there. Okay, to generate the assembly code, we will write gcc -s hello.c -o. Now output file name will be hello.s. Now we have the hello.s as well. Now if I will open this hello.s, you can see that it is written in binary, so we cannot read it. So for that, I will just open in the command prompt. So I will write object term -d hello.s. So here you can see that it is generating the assembly code for our C code. So you can see a lot of string because we have included the header file, and in the end there will be a main function as well. So you can see over here that main function, right, which is basically calling a stack pointer, and then there will be a main function, and then copy of data and everything will be over here. So your program will get executed on the stack. So this is how our .s assembly code look like. So I hope you are now clear with compiler. Compiler will convert our pre-processed source code into the assembly code. The next step is the assembler. The job of assembler is to convert the assembly code into the machine code. So it will have an extension of .o, and we will generate a hello.o file with the help of this assembler. So to generate the .o file, we will write gcc -c, then our source code file hello.c, then output hello.o, right? So now if we look into this folder, now we will also have this hello.o file, and again if I will open it, it will be in the binary format. So to simplify this process, I will write object dump -d hello.o. So this is how basically our .o file look like. It will have some assembly instruction as well as this hex values, right? And here also, as I said, first this instruction will copy the value on the stack and write, and then it will execute, and it will pop those stack pointer again. So this is all about our .o file. So now I am pretty much sure that you are also now clear with assembler. So basically sometimes we are skipping all this step and we are directly generating this .o file, which will be a machine code. And then next is a linker. So linker is basically linking all the files. It will link multiple object file that we have seen, or machine code files, or from different library if we have some object file, that will also get linked. And finally it will generate one single output file, which is .exe. So if we are using a Windows, in our case it will be a .exe. If you are using Linux, it will be a .out. So whatever I'm talking about with respect to the Windows system only. So that's why it is a hello.exe file. So now we will see how we can generate this exe file with the help of linker. So now we will write gcc, then hello.o, then our output file let's say exe. So here you can see that we have our application file as ready, right? This is hello.exe, and basically we will run this file, and this will copy our data onto the stack, and it will be run and it will provide the output. So here the last step is to run the executable code, right? So it will basically load and run the code on the operating system. So we will just run this hello.exe file and we will verify the output. So now I will just call the hello.exe file that we have generated. We will just press enter. So here you can see that it has generated output of var b10 and pre10. So basically this printf statement is displayed over here, and you can also see that we got a pre-a value as a 10, which was defined over here, and earlier variable b was 7, but now we have copied the value of pre-a into var b. So that's why var b is also 10 over here. So this is how the C program will get executed, right? From the source code, it will do the pre-processing, then compiler, assembler, and finally linker will link all the object file and generate the exe file. So whatever we have seen is a step by step. In most of the IDE nowadays, you need to click on run button and it will run the program. So we will see with Visual Studio Code. So I have just opened the same code that we were discussing. So in order to run this code, we will just click over here, run code. and you can see that it has executed the code as well as the output is also generated. So whatever we have seen a step by step, it has just done in a second, or in fact even a less than a second over here, right? And if you want to see, like here you can see that this is how the command is given to generate the object file or final executable file. So I hope you are clear with basic introduction to C. Thank you so much for watching this video.